Okay, we're here in Virginia on March 25th, 2015 with Isabella Karle. Our first question is to please say your name and spell it.
My name is Isabella Karle, Isabelle, and the last name Karle.
Great. If you could tell us a little bit about where you were born and when.
I was born in Detroit, Michigan on December 2nd, 1921.
And did you grow up in Detroit?
Yes, I grew up there.
What kind of an education did you have growing up?
I didn't speak English until I went to elementary school. The home language was Polish. And my mother, although she never had attended any schools, knew both Polish and English, so she taught me to read in Polish. I learned arithmetic from her and such things. But by the time I got to be 6 years old, it was mandatory that I go to the elementary school, in which only English was spoken, that is, by the teacher. I think every student spoke a different European language. So that was an interesting background, I thought. But we all spoke English after the first year. My father came to this country at about the age of 15. He came from a society that had classes in it, like the English society, for example. So if he had come from a peasant family, I don't know if they would have immigrated or if they would have had much of a future in this country. He came to join his half-brother who emigrated a little earlier. And all of this was economic because it was the oldest son in the family who inherited the estate. And the younger ones had to find other means of support. My father volunteered as a soldier in World War I. He was living in Duluth, Minnesota then, with an older half-brother who also emigrated because there was still another older brother who inherited the works, the estate. And when my father joined the United States Army, they were quite happy with him because he spoke Russian, so that they could send him to Archangel. If you know this little part of American history of World War I, the Americans took over from the English after the English gave up fighting the Russians up in above the Arctic Circle. And so, since he could speak Russian, he didn't have a high rank in the Army. On the other hand, he had a very important job. He was the town censor. He translated from Russian to Polish, from Russian to English and vice versa. And so he survived the war quite well, except for the weather. You know, it was up in Archangel, where it's pretty far north above the Arctic Circle. And then he came back to the United States, and my mother was brought here by her father, who had a large family, whose wife died, who married again, who then she had a stepmother whom she couldn't stand, neither could most of the other children. And so at an early age, she went to live with her oldest sister. But she had no formal education at all. So they were living in Wilmington, Delaware to begin with. And the word had spread that there were much better opportunities for employment in Detroit. And so they moved to Detroit, and at the age of 12, she went to work in a cigar factory. Fortunately, whoever hired her didn't have her wrap cigars. You know what the common problem there was amongst the women? That after the cigar was rolled, the end of it was chewed with human teeth. And the women who did that for any number of years had very brown teeth that were not rotten, but worn off, just worn off halfway. And I knew some of those women. Well, fortunately, somebody thought that my mother was too young to do that, and all she did was put the bands on cigars to put into boxes. I'd often wondered how that industry was present in Detroit. I always heard that automobiles and refrigerators were what was built in Michigan, but somehow or other the cigar makers were also busy there. But she taught herself to read both in English and in Polish. She taught herself arithmetic. So by the time she got married, she was already having sort of middle-class occupations, except for World War I, in which she was making uniforms for soldiers. But after she married my father, and her brother married an American-born woman who had a background of Polish and German. The two women became friends, and they decided to go in the restaurant business. So my earliest recollections were in the back rooms of the restaurant. It was a restaurant, not a full-fledged one. It served breakfast and it served large lunches to construction people. It was, a building with tables and chairs and counters and full meals. And my mother realized fairly early that I liked numbers. And I soon became the accountant, so to speak. Fresh meat was delivered every day, and the butcher left a bill, and that had to be paid once a week. So once a week I added up all the numbers of the money that was owed him. And then my mother decided that if I could do that, I could learn to read and write too. So before I went to school, I could read and write in Polish, which was handy because the alphabet is the same except for 3 letters. So I knew how to sound out words, I knew the alphabet, I knew how to write them down. I could do arithmetic as far as adding was concerned. So by the time I went to school, in the public schools, I already had these skills, and I was sort of the top girl in the class, and the teachers used to wonder how I did that since I didn't speak English. And I went to the school rather quickly. in that I didn't go to 2nd grade. I didn't go through 5th grade. There was another grade I didn't go through, so that I was young when I got to high school. There was no hesitation to put students ahead if they could manage the work. Depression days had come in the late 1920s. There wasn't enough money to pay teachers anyway, or to have large schools.
How did the Great Depression affect your family?
My father was fortunate in that he went to work for the transportation system in Detroit, which was city-run. And they kept the buses and the streetcars running during the Depression. Not many of them, but he kept working for the transportation system. So we were never forced to be on welfare like, hey, I suppose 80% of the city was. My mother was very clever about all kinds of things. We always canned our fruits and vegetables and chickens and whatever was cheap in the summertime, so that we had good, interesting food in the wintertime. Otherwise, it would have been mostly potatoes and cabbage that people survived on. And my mother was also clever about making clothes, so I always had nice clothes to wear to school. And she saved her pennies so that we could see some of the United States. And at first, my father did have a car. We saved enough money that we traveled around Michigan. Even went to see the Sioux Canal, you know, for the boats to come from Lake Superior into Lake Huron, where the level changes by 20 feet. We saw the first lock that was built for boats, and that opened up a lot of trade. We drove down to Florida once. In other words, my parents were able to scrimp enough or be clever enough to do it yourself when needed, that we had at least a week's vacation as I was growing up, which was not the case with most everybody else whom I knew. I didn't know what science meant until I was in high school. And I read that if I had wanted to go to a university, I would have to have some coursework in high school in science. So I asked my homeroom teacher, who was also, I don't remember the name of such a person, but she kept all of our records, school records, made all the announcements and that sort of thing. So she told me, well, you could have chemistry, or you could have physics, or you could have biology. One will be sufficient. So I asked her about them. She didn't know anything about the sciences. So I picked one out of the air, which was chemistry. And that was a fortunate choice, because I thought that the teacher, who was a female chemistry teacher, unusual in those days, was a very good teacher. And she was the one who sparked a very intense interest in what I was learning in her class. My father was quite disappointed. He said, "Why don't you want to be a lawyer?" I always wanted to be a lawyer. "I know, Daddy, you always wanted to be a lawyer." I couldn't stand being a lawyer. So he gave up after a while, and I could be a chemist, about which he didn't know anything, but I seemed to prosper.
And so then did you decide to go on to university in science?
Yes, I did. I started off in Wayne, what is now Wayne State University. It used to be the old Central High School building in the middle of Detroit, and it was set up as a college beyond high school for all of the children who, in 1929 or whatever it was, couldn't go away to college but had to live at home because of the bad economic times. And I was there for one semester when a former high school teacher of mine, came to my house and told me that the following day there was going to be a statewide examination for a scholarship to the University of Michigan in Ann Arbor. And she would come and get me, and I could take that examination, even though I was already a freshman at Wayne University, which I did take, and I came out fourth in the state, and they were giving out 15 or 20 scholarships for the whole state, so that was easy. I got a 4-year scholarship to go to Ann Arbor.
And so in Ann Arbor, did you continue studying chemistry?
Yes, I did. I started the chemistry course at Wayne State, and I, again, had a very interesting teacher. And he thought I was interesting, too. I happened to be the only girl in a class of about 40 or 50. And I seemed to know what he was talking about much better than anybody else in the class. And he said, of course you're going to go on to graduate school. Well, that was the first I heard of graduate school, and that one gets master's degrees and PhDs. So that became my goal. When I got the 4-year scholarship to the University of Michigan, I immediately enrolled in a chemistry program and stayed there.
So it was, you were the only woman as a chemistry major. Did you feel singled out, or did you not really think about it very much, being the only woman?
I didn't think much about it. At Wayne University, I was the only girl in the class, but that didn't seem to matter. And at the University of Michigan, I think there were three others who went through the course with me up to a point, but then they weren't intending to go on to graduate school, and so after 3 years of chemistry major, that was sufficient to look for a position in which chemistry was needed.
So did you go straight to graduate school after Ann Arbor?
I stayed in Ann Arbor. The World War II had come along then, and students were urged to stay at whatever university they were at to have the least possible movement around the country, because that just took energy on the part of the various governments. And so I stayed at the University of Michigan for my master's and my PhD. Meanwhile, I did get additional fellowships at the University of Michigan so that I could afford it.
How old were you when you got your PhD?
23, 23rd birthday.
That's very impressive. Did you meet your husband at Jerome at Michigan?
Yes. His path through school was somewhat different than mine. He had never gone to school where there were girls. he was brought up in Brooklyn, and apparently even in elementary school, the girls and the boys were separated. In high school, they were separated. And then he went to City College, which was all male at the time. So I teased him that the first girl he ever met in school was me. But he was a good student, and he got through school in record time also. And I'm sure that part of that was trying to push students along as fast as possible. That meant fewer teachers for the number of students they had to teach. Less money spent on teachers because of the economic times. Then he went to Harvard for a year, and although he had a straight A report card for his master's degree, which he did earn at Harvard, they would not give him a fellowship. Wrong background. He was Jewish. They said they had enough Jewish students from New York City, and they didn't want any more at Harvard. And that, of course, disappointed him considerably. He happened to get a job with the New York City or New York State Water Department to work in their laboratories. And he, while he was there, I think it was a period of about 2 years, developed the fluoride tests for fluoride's content of public water supplies, which I think is still used. And earned enough money to travel to the Midwest, thinking that perhaps the atmosphere would be different than that on the East Coast. Came to Michigan and decided that he should study chemistry instead of biology. And so I found him standing next to me in our physical chemistry laboratory.
So the two of you met in the laboratory.
Yes. This was the first day of laboratory for physical chemistry, and it was supposed to be all afternoon laboratory. And we were assigned working space in alphabetical order, and my name started with an L. My husband's was a K. Of course, I didn't know him at the time. And I was always top dog in the chemistry classes at Michigan. I didn't meet him until I was a senior, and he had to make up some of the chemistry classes because he had been, his degrees were in biology. So I walked into the physical chemistry laboratory, and there's a young man in the desk next to mine with his apparatus all set up, running his experiment. And so I don't think I was very polite about it. I asked him, how did he get in here early and have everything all set up? And he didn't like that. And so we didn't talk to each other for a while. First examination came along, and he decided to ask me, and how did you answer this question and that one? And then he realized that I knew what I was talking about. And so it was still a while later that he asked to take me to a concert that was going on at Hill Auditorium. And we began to see each other more. But again, it was at a time when funds were very short. It was, we didn't go to the movie house on campus because that cost 35 cents. Whereas if we walked downtown in Ann Arbor, we could see a movie for 15 cents. And that did make a difference because the difference in prices almost bought a good meal in a restaurant. I suppose it sort of set a pattern of living. What we could do for ourselves, we did for ourselves, and saved the money for other things like taking little kids on boat trips to Europe.
Did you dress up special for your first date with him?
No, he was annoyed at that. The Messiah was being performed at the Hill Auditorium in Hill, and he asked if I wouldn't accompany him there. Well, I had gone through a whole day of classes, plus a laboratory, plus teaching freshman laboratory. And by the time I got home, well, where I lived, and had a bit of supper, I just was in no mood for changing clothes to go to a performance. So I just went as was. And he thought that that wasn't really proper of me. I could have put on a dress.
But I guess in the end, it made no difference.
That's correct. I think what characterized both his background and mine was that the Depression days really hurt an awful lot of people. Now, it's true that in my family, my mother and father were able to manage their lives in such a way that we could squeeze a week's worth of vacation for the year and see things that other people couldn't because they spent all their money otherwise. I got married when I was 20. I had my bachelor's degree by then. And it must have been about 2 years later.
Okay. How did you get involved in the Manhattan Project?
Well, World War II had come along, and many of the male students, almost all eligible ones, were already drafted into the armed forces. Those who were studying a useful subject like chemistry were often put into a bomb disposal unit. We knew a number of our friends who did such work. Fortunately, they all survived and came back. And the rule of thumb for draft boards was to defer the chemistry students who were already juniors or seniors or graduate students until they got their degree. And after they got their degree, they got special treatment. The special treatment being bomb disposals or other things that had something to do with chemistry around where the American forces were. And he was selected to go to Chicago for a secret project. So I didn't know what he was doing, except that it was chemistry and it was exciting. It wasn't until I got my degree perhaps a half a year later, that I was asked if I wouldn't come and work where he was working, although I didn't know what it was that he was doing, but that meant that we could live together again, see each other. And so it wasn't until I arrived in Chicago that I learned slowly. I think the people who were directing the place wanted to know how good their security was. So I wasn't told what I was about to do. There were certain books I should have read the first month or so, and it turned out to be the plutonium project in what was called new chemistry at the University of Chicago. And what that meant was that plutonium was already being manufactured, if you could call it that, at Oak Ridge, but it was in a rather impure state. The material looked sort of soapy, like dirty green soap. There wasn't much of it. The people who got samples to work on had to see their samples under a microscope, pick out the pieces. And the objective was to purify it so that my group was making the halides, that's the chlorides, bromides, iodides of plutonium. And it should contain only that material and no foreign materials. In practical terms, it meant that I got a few lumps of plutonium oxide in a sort of impure state, and I was supposed to make a compound of pure chloride. And there were, of course, no rules. This is a new element. Its chemistry was unknown. That was part of our objective, to find out how it behaves with other chemicals and how to synthesize a new compound containing plutonium that was only plutonium chloride in my case, with no impurities. I could see why they selected that project for me, because in graduate school, although I was working on other problems, I was familiar with vacuum lines. Vacuum lines were quite a new thing in science. I was familiar on how to measure very low pressures in vacuum lines, how to blow glass, to put the glass tubes together, put stopcocks in, how to cool or heat. In other words, I had that background in getting my PhD. This was all very new at that time in the history of science. And I was given a space in which to erect my vacuum line. And every week I got a few lumps of the impure plutonium oxide from Oak Ridge. And I was supposed to make the chloride, which I did. There were innovations that had to take place, because in order to get pure compounds, one often heats up the material and then collects the vapor on a cooler place, and that purifies it in a sense, depending upon how much you heated up the impure material. So the first things I found out was that plutonium chloride had a melting point or boiling point somewhere near 1,000 degrees centigrade. If you are familiar with laboratories, you know there's nothing that withstands 1,000 degree centigrade. And so the vacuum lines couldn't be what's the kind of glass called? Pyrex, because the Pyrex would melt immediately. They had to be made from silica. The silica tubes were available, but only in tubes or stock. Not, yes, some stopcocks, but not really. And so I had to devise other conditions for combining the impure plutonium oxide with a carbon-containing chloride compound, and that the chlorine should separate from the chloride compound and attach itself to the plutonium metal. And this is all uncharted territory. But fortunately for me, plutonium was not so very different from uranium in its chemical properties. So I had to find out what I could in the library about uranium compounds, which was possible. In fact, it was an interesting experience. Our laboratory was on the grounds of the University of Chicago. Now, there was a very specialized library in downtown Chicago. It was a technical library. And I could take the IC Illinois Central train that had a stop not too far from the university to downtown Chicago to the library, look up what I needed, and be back within an hour. So I thought that was very civil of the city of Chicago to have one, a rather extensive library, and two, a good transportation system, a fast one. And I decided on how to go about starting with the impure plutonium oxide, heating up my apparatus to close to 1,000 degrees centigrade, which meant that I had to use silicon dioxide tubing for the glasswork. That was the only material that I or anybody else knew of that was inert and yet wouldn't melt under 1,000 degrees. And I put that all together, and I ran my experiments, and yes, indeed, I managed to synthesize plutonium chloride in about a dozen different ways. That, in a nutshell, is what I did. What happened to the pure plutonium chloride after that, I don't know.
Was it challenging to work with plutonium because of the radiation?
Yes, of course. I mean, we had to be careful. I do have 3 healthy children. I wondered about that for a while. But I didn't know of any bad effects on people. except for the few who died from inhaling any vapors of the plutonium compounds.
What kinds of safety precautions did they have you take when using plutonium?
Each one of us every day had to take a great big tablet like that of, what was it, calcium chloride? I don't remember. I should. That's the reason for doing that. It was reasoned that our bones are mostly calcium, and radium displaces the calcium in the bones if you're exposed to radium. And that was a product that people would stay away from. And so they thought that if we had an overabundance of calcium in our bloodstream, that the plutonium wouldn't settle in the bones instead.
Did they monitor your radiation levels or test you before you left the laboratory?
Oh, once a week we went through various radiation reading devices, had our fingers counted. Always carried a meter along that would ring a bell in case it came across some radiation. So it was somewhat primitive, but at least there were attempts to monitor the atmosphere. In our laboratory, there was another person, Joe Katz, who was working on a bromide with the same intentions, that is to make pure plutonium bromide. Another one who's working on the iodide. The bromide crystals also grew nicely. The one who was working on the iodide had more difficulties because plutonium iodide just didn't crystallize nicely. It just didn't behave properly. But that was his problem. And then there was one working on a fluoride. And that was the most dangerous of all because plutonium fluoride was a gas. And it could escape in the air. And it did at times. But I don't think any of us suffered from that. And I say that because at the, was it the 50th anniversary of the project, there was an American Chemical Society meeting in Florida, and I was asked to present a paper about what happened to the people who worked on the halides in the same environment that I did. And they were all healthy. They were all well placed in their own particular specialties in chemistry or chemical engineering. And everything was happy from that point of view. So we managed to stay healthy. People who were present at the bombs that were set off afterwards, after the war, and you may have heard or known, they set them off in various isolated islands in the Pacific. Some of those people got too much radiation when the bombs went off, and a couple of people whom I knew did die from radiation, having been present at the testing in the Pacific. I don't know what has happened to the isolated islands where this had happened. I don't know if anybody, if you are aware that such a thing happened. There was a lot of writing about it in the newspapers and on news reports. And I think the testing stopped after a while because it was irradiating some of the islands too much, and a number of people got sick and some died. But we did not experience any of that. In some sense, we were treated specially. The Coca-Cola company had just come out with a device in which, after you put in your 10 cents worth or whatever it costs then, a cup would drop down, water would come from one side, ice cubes from another, and Coca-Cola syrup from a third spigot. And it was a popular place to pick up Cokes. Well, one day at lunchtime, we all had to go elsewhere to eat lunch. We weren't supposed to eat anything in the laboratory. I was coming back from lunch a little early and walking down the hallway past the Coke machine, and suddenly my radiation meter went off scale. And that, of course, alerted me that something was wrong with the Coke machine. And so I called the few people who were around to, if we could figure out what it was. Well, what it turned out to be was that while everybody was out to lunch, the delivery man who delivered the syrup couldn't find his hose and funnel. And he didn't want to go through security again at the entranceway, so that he looked into the closest laboratory and he saw a length of pipe rubber pipe that would suit him quite well. So he poured the syrup through this rubber hose into the container for the syrup and left. And what he didn't realize is that he picked up a very radioactive piece of laboratory equipment. And the syrup went through it and, of course, contaminated the whole machine. Fortunately, quite by accident, I was walking by soon enough before anybody had drunk from the machine. And it registered on my meter, and bells went off, and it was discovered where it was and how it was. So by the next day, we had a newer Coke machine in which it was impossible to do anything of that sort because the Coke came in bottles, already bottled elsewhere.
That's a great story. Do you know what your husband worked on during the Manhattan Project?
I know what he worked on in general. I didn't really know in particular what it was. He also started with plutonium oxide, and he had tried, well, he was assigned to try to make pure metal, not a plutonium compound, but pure plutonium metal from the oxide. And that required different approaches to treating the plutonium oxide to come out with a metal.
So, were you not allowed to talk about your work to each other because of the secrecy?
That was mostly it. We didn't. because we just made it a point not to talk about, well, to anybody what we were doing.
Did you know that the end project was going to be an atomic bomb?
That was sort of pie in the sky at the time I was working there. The mood around the laboratory in Chicago at the time we were there was that it wasn't not the Japanese. It was the Germans who it was known were also trying to make pure. Did they know about plutonium? We heard rumors, but there were only rumors that they were making something that if it exploded would have blown half of Europe out of the world. The Germans did not succeed in doing what they were doing, and as far as we heard, and most of us were not in on most of the discussions except for our limited area of chemistry or physics or engineering. We were trying to make something that would have been more concentrated rather than as widespread as what the Germans were doing or trying to do.
Did you know anything about the other Manhattan Project related work that was going on around the country?
Not much. We knew that people came to visit us from Oak Ridge, specialized people, from Oak Ridge, from the other. There was a laboratory in Washington State, wasn't there?
Hanford?
Yes. And the laboratory in Arizona.
Los Alamos, New Mexico?
Yes. So we knew of the existence of the other laboratories. And some of the senior chemists, physicists, and so forth would make the tour around the country every once in a while, every few weeks, to give us a briefing as to what, not what we wanted to hear, but what they were willing to tell us. So we knew about other activities.
How did the top secret nature of the Manhattan Project affect your day-to-day work?
Not much. I don't think. I looked like another student at the University of Chicago. I still wore pigtails. I was 23 at the time. Looked fairly young. I could have been a student. And I walked around campus freely, except security one day found out that I was carrying these samples of plutonium chloride that I had made. They were sealed in a glass tube, which was in my pocket, and I walked across campus to the physics building where Professor Zachariasen was an X-ray man who would examine the samples with X-rays. He had been a professor at the University of Chicago, and he continued to work for the project and lend his services when desired. And so I would walk across campus with these samples in my pocket, and nobody knew until somebody told security. And then I had 2 guards walk with me. And if there were 2 guards dressed as guards walking with me between them, everybody who looked at us thought that was peculiar and something peculiar was going on. So their security measures didn't always measure up to what they should have been.
Were there a lot of military personnel around, or was it mostly just the scientists?
There were no military people there.
Were you the only woman who was working in the laboratory on the project?
I was the only woman scientist no, there was one other lady. She was a number of years my senior. And we were friendly since we were the only two female scientists. There were, of course, women as technicians. There were women as office employees, typists, that sort of thing. But not scientists, except for the two I mentioned. We were in a building called New Chemistry, and almost everybody in there that whom I knew was associated with chemical problems concerning plutonium. So I did not meet with many, or almost nobody from physics.
Were there any African Americans who were working on the project that you knew?
No.
How many days a week did you work?
We worked our regular 40 hours a week on paper. We stayed all night if needed. There was no such thing as overtime, but a good many people had to with tend their experiments around the clock.
Were you paid fairly well?
I was paid $3,000 a year. And that was a pretty good salary because a university instructor would get maybe $2,400 a year. So that was $600 more.
What did you and Jerome do to relax or for recreation? Did you relax with the other scientists, or?
Somewhat. We went out to the Indiana Dunes State Park because the IC Railroad, Illinois Central, had an interurban train. So in an hour or so we could go to the state park and climb the sand dunes, put our feet in the lake. One of the things my husband and I did quite a bit of was buying furniture. We had been married and lived in a furnished apartment before we went out to Chicago. And so all we had as furniture in the apartment that we happened to get quite near the university. It was a nice one. The living room had a very large Murphy bed in it, so we opened the doors and the bed came down, so we had a place to sleep on. We owned a card table and 4 folding chairs, so we had a place to eat on. And then furniture was not particularly available in any of the stores, but we still managed to buy a few pieces. That china cabinet came from Chicago. Our desk came from, what was the big department store?
Sears? Marshall Fields.
Pardon?
Marshall Fields.
Marshall Fields, yes. And that was an interesting store to go shopping in. On the top floors, they would have very elegant furniture, which we couldn't afford, of course. We went to the Chicago Zoo, and And not much. Well, walking along the sand beach, not that far from where our apartment was. There was one day, though, that was very bad. It was a nice spring day, much warmer than people expected. And that was one of the days that we took the train out to the Indiana Dunes to walk around the dunes. A lot of people got into their bathing suits and went to the beach. It was not far from where we lived. Others pulled out their boats and were out on the lake. And one of these tremendous waves came through Lake Michigan, starting from the north and going towards Chicago, and inundated the beaches and washed many people into the water, and they drowned. And that was a very sad day. Apparently, such a thing has happened in Lake Michigan every, I don't know, 50, 100 years. And it happened that day.
Did you and the other scientists feel a sense of urgency to work on the project with regard to the plutonium?
Yes, because we didn't know at what stage the Germans were in their, they didn't work on plutonium, they worked on uranium, I think. But at any rate, every once in a while there were rumors as to how they were progressing, and we didn't want the Germans to come out with explosives that would be dangerous to us and not controlled by us.
How did you find out about the atomic bomb being dropped on Hiroshima?
We no longer worked at Chicago. Our part was done, and we left and went back to the University of Michigan, so we heard it on the radio. And that was nobody knew that it was going to succeed. There was always that question, will it succeed when it has to? And so that was the first big surprise when we heard it on the radio news programs. And then we didn't know whether to be happy about it succeeding or not happy, because one, it did end the war quickly, but two, so many people were damaged or killed in the process. And hardly a happy day.
Were you surprised that it was used against Japan and not Germany? I know the war with Germany was over at that point, but...
I guess not, no, because what we did know from the news that was broadcast on radio programs, and that the United States had very many troops in the islands off Japan, and that there was going to be, or it was speculated that there was going to be a big attack, but nobody talked about the atom bomb. That was not a subject of interest. After all, how could it work? So the secret was kept pretty well.
Did you know many of the top Manhattan Project scientists, such as Enrico Fermi at Chicago?
Yes and no. My husband went to Chicago several months before I did because we didn't finish up. I didn't finish up my PhD at the same time he did. But then during that time, he had contact with Fermi. By the time I went, Fermi came for visits, but you see, there were no airplanes in those days. You visited cross country by taking a train, so it took a while to visit the various laboratories around the country. But I knew who he was. I had heard him a number of times because there were the Thursday night lectures by visitors from the other laboratories who happened to be in town.
Did you ever see Oppenheimer or Groves at Chicago?
Not that I remember.
Who were some of the other scientists that you were friendly with at Chicago?
Well, Seaborg was, he's the man who discovered these transuranium materials, and he got a Nobel Prize for it. So he was the head of our laboratory. We'd see him not on a daily basis, but he was around. And visible. The other people, I knew their names. I went to hear them speak when they happened to be coming through Chicago and to give us our Thursday night lectures as to what I suppose we were allowed to hear that was happening in other places. So we knew of the existence of the other laboratories and occasionally saw some of their personnel.
Anything else you want to say specifically about the Manhattan Project before I move on to another topic?
At the 50th anniversary year, the American Chemical Society had a symposium that was held in Florida. And at that time, I sort of summarized what the other people in my group had been doing and what happened to them. And it was gratifying and interesting that of the other people whom I did know in Chicago who were in the laboratory then, all had become heads of chemistry departments or metallurgy or stayed on at, what is the name of the place that still exists in Chicago? Argonne?
Argonne.
Argonne, yes. Some of them stayed there and became well known for their metallurgical work. And so I was very happy that everybody I knew had progressed well in their profession. Not always with plutonium or with heavy metals, but in chemistry or biochemistry. Like the head of the metals and words escape me. And metal products up in Upper Michigan, for example, one of the people became the head of the department at the university. And there were quite a few university people. Some went into the industry, and then it was not that easy to find out what they were doing, but at least it seemed that they continued in science.
Did you know Larry Bartell?
Yes, but I knew him from Michigan. He was a year behind me in school. His mother, I think, was the first woman who got an engineering degree at the University of Michigan. His father was a colloids professor in the chemistry department. And so we were in a number of classes together. And yes, we kept up our friendship afterwards.
Do you feel that your work on the Manhattan Project influenced your later career in any way?
Well, I was presented with a number of challenging problems in the form of experimental work that I had to devise in order to come to get the results that I wanted to. So it gave me good practice in attacking quite unknown problems. I met a number of people, but I did know some of them otherwise, and we stayed friends. I met one person, unfortunately, who got irradiated at one of the experiments after the war, but experiments with exploding radioactive materials on the islands in the Pacific.
You and your husband both had very distinguished careers, so can you talk a little bit about your post-Manhattan Project work?
We went back to the University of Michigan, at which time I was appointed instructor in chemistry, and I was teaching the engineering students freshman chemistry, which I thought was rather amusing. My husband, the war had not been over yet, and my husband was teaching groups of young Army recruits, but I don't remember what it was that he was teaching them before they went out in the field. After the war ended, we got an invitation, both of us, to have a permanent job at the Naval Research Laboratory. We didn't know what it was, but we did know Dr. Zisman, who was head of chemistry there. And he said it wasn't for him that he was looking for people, but for Dr. Herbert Friedman. Are you familiar at all with the name?
I'm afraid I don't.
He sort of instituted the upper atmosphere research from, well, satellites eventually, but from balloons that were sent up from Earth with measuring devices on them. And he was the person we went to work with when we came to Washington. And it soon became obvious that although we did our work there and we were relatively successful, that we would be happier doing our own thing, which was diffraction work. And so we built the first electron diffraction apparatus. In those days, you didn't go out and buy a piece of apparatus, you made it yourself. With help, of course. There was a book on a table here. I just got this in the mail yesterday, and that's a picture of me in the early days.
Can you hold it up for the camera?
I don't know if you can see it. Was an electron diffraction apparatus that my husband designed, and I assembled from all the pieces that came from the shops, because it was all built at the Naval Research Laboratory and put together and aligned and made to work. What it did was that it was possible to get an electron beam to traverse vertically from the electron gun at the top to a sample that was squirted into a vacuum. And then there were a row of photographic plates underneath, and to record the diffraction pattern. And then that sort of thing, we were able to measure the exact geometry of molecules in a vapor state. And the plans for that electron diffraction apparatus were sent to whomever wanted them around the world. It's in other laboratories. And Japanese chemists were quite interested in it. Russians, Germans, oh, of course, the Norwegians. So that became sort of the standard electron diffraction apparatus. Oh, the Hungarians too, around the world. Slowly, we realized there was a limited number of molecules that can be vaporized to structure you can get, and much of that had already been done, that we ought to look at solids and go into the field of X-ray diffraction on solid samples. And it was there that my husband, with Herb Hauptmann, did the mathematics that helped solve the so-called phase problem in crystallography. And I was the one who collected the data and did all the practical experiments. And so he got the Nobel Prize for that work. I got other awards. And I spent the rest of my career at the laboratory working on various naturally occurring materials. For example, on the toxins that the frogs have in their skins, the poison dart frogs. Some people at the National Institutes of Health were interested in those toxins because it was known that if you killed a bird or another small animal with the poison darts, you could still eat the meat. And why was that? Why did the toxin, why was it so toxic to the other animals, and yet it didn't do any harm if you ate the animals after they died? And so I collaborated with a number of people at the National Institutes of Health who indeed isolated the toxins from the frogs and gave me crystals, and I could, but the chemistry was so different than anything they had expected that it was when I had done structure of the materials as to which atom was attached to which that we could find out what the formulas were. And it was interesting that the animals that were killed with the toxins were edible as long as there wasn't any connection to the bloodstream in the person or animal eating the animals that were killed with the toxins. And it was a whole new kind of chemistry. And we proceeded to other materials, poison mushrooms, for example, and isolated I didn't do this, my collaborators did in Germany and in the United States, a lot of it at the National Institutes of Health. Isolated these very strange materials, and I was able to do this crystal structure of them and find out which atom was attached to which and how, and then they could be synthesized and studied for other purposes. It was hoped that perhaps these materials could revive an animal or a person who died from a heart attack, because it would start the heart beating again. But it could never be controlled closely enough to become a drug of use.
Did you and your husband work on a lot of projects together throughout your career?
Yes and no. We worked next to each other, but we didn't really work together. He did a lot of the theoretical work, and I did the experimental work. And so when it was appropriate, we would publish papers together. Otherwise, we had our other collaborators.
Was it unusual for there to be a husband and wife team in the lab?
Yes. We weren't the only ones. There were others for shorter periods of time, and they were in other departments, and I don't know why they either left of their own free will or otherwise.
Was your husband surprised when he won the Nobel Prize?
Yes. He thought it would come much earlier, and then we forgot about it. No, the Nobel Committee we decided, had completely forgot about him. And when it finally did come, it was quite a surprise.
Can you tell us a little bit about the awards that you won? I know you had a very distinguished career.
The first award came from the Women in Science, no, Women in Engineering, Society. And that was for building the electron diffraction apparatus. So I was rather surprised and pleased that the women engineers were the ones who gave me my first award. There were quite a number of awards, most of the ones that were available at the laboratory. one at one time or another. The laboratory, the Naval Research Laboratory, has a room dedicated to the work that my husband and I did, and all such things are listed there.
That's really wonderful.
They have every year there's a special symposium on a special topic. The special topic being almost anything in science and engineering, but special in the sense that it might be just developing. And so such a meeting is held once a year for 2 days with invited speakers, and it doesn't have anything to do with the work that we did except the atmosphere.
As a woman in science, did you ever face any discrimination, or was everyone very open to women in the laboratory?
When I went through college, sometimes I was the only girl in the class. And that didn't seem to bother me, and it didn't seem to bother most of the students. I think there were a few instructors or professors that didn't like the idea of having a woman in the class. But they were still quite fair about it, just not very friendly. Both my husband and I found the Naval Research Laboratory a good place to work, in the sense that the funding was rather good, and that there was no particular discrimination. I'm sure there are people who didn't like the idea of having women around, but they didn't get in my way. And both of us found that we could work on problems that were of interest both to us and to the Navy, one way or another. He got his PhD in chemistry, but what he got the Nobel Prize for, that is a portrait made by a lady who painted Nobel Prize winners in the United States. Before he never really did chemistry research. He did the mathematics for chemistry research. And so he suddenly became popular not only with the chemists, because of some of the work he did in chemistry, but also the mathematicians who don't have a Nobel Prize category. And here was somebody doing mathematics primarily, and yet garnering the Nobel Prize in chemistry. And he spent most of his life at the Naval Research Laboratory in mathematically related problems. So most of them had a practical feature to them also, to make us legal. But they depended heavily on the mathematics that went along. He was a good experimentalist, but he didn't like to be an experimentalist. Although he did all kinds of repairs around the house, additions and that sort of thing.
Great. Well, anything else you want to share before we wrap this up?
Well, we had a good life together. We sort of, when we went traveling, and we often traveled around the world for periods of, let's say, 2 weeks lectures in Japan or 2 weeks lectures somewhere in England. If it were summertime, we took those people along. We had 3 daughters. And so you saw quite a bit of the world, didn't you? I suppose all I can say is that I enjoyed all the scientific work that I was involved in. I enjoyed bringing up a family. I also enjoyed running around the world. So all kinds of good things happened. And fortunately, we didn't have any disasters, catastrophes, bad health. And not all people are that fortunate.